Now let's write the Java implementation for finding the maximum value in a sorted and rotated array according to the algorithm that we have discussed previously using binary search approach. So here I have created the new file called max value in sorted and rotated array, and I have created the class and added the function declaration, as well as I have written the main method where I have called that function as well, so that we don't spend more time while implementing. And let's just get through the implementation of the main function as part of this video right now. So here, whatever the array that we have got, right, it is basically sorted in the ascending order and the values are basically rotated. That means from the beginning certain number of values we have taken and we have moved them back to the array. As a result, whatever the array that we have got, right, here we basically have two sorted arrays in the array input that we get. Now our aim is to find the index of the maximum value and return that index back to the user. So that is our aim. So here, just like in any other problems that we have solved, first of all let's just try to read the length so that we can use it when we apply the binary searching. First of all, to write the exclusive condition for checking if at all if the array that we have got is empty, in that case the length will be 0 and let's just return -1 here itself. If this is not the case, then we actually have the values. Now let's write the logic for getting the maximum values index using the binary search. Here let's just define variable start and let's also define variable end. This end will be the last index, which is nothing but length -1. Similarly here let's define one middle variable and initialize it with -1. Now all we do is we will run a loop as long as the start is less than end. Okay, now what we will do, we will calculate the middle. Middle is nothing but start plus end divided by 2, and here is where the main logic we need to write. If at all the value we have at the middle, if it is greater than whatever the value we have at the start, that means we have the value at the beginning of the array. That means at the start of the at the start index of the array. Now we actually have the value at the middle of the array and we also have the value at the start of the array. Now this middle value is greater than whatever the value we have at the start. That means the value or the maximum value could be the value at the middle or the value after the middle, right? So to continue our search here, what I will do is I will simply update the start index with middle. Remember that since it is a sorted and rotated array, the maximum value could be middle or any value after middle, right? That's the reason why here we have not updated the start with middle +1, rather we have simply updated the start with middle itself. If this is not the case, the obvious other scenarios could be less than or equal to, right? In that case, whatever the value we have at the middle, this is less than or equal to whatever the value we have at the start. That means the larger value is there on the left part of the array. To continue the search on the left part of the array, end we will simply update it with middle, so that we will continue and search in the left part of the array. Okay, so in the end, whatever the value we get inside the start index, that index will hold the index of the maximum value in the sorted and rotated array. As a result, we will simply return start here. Whatever the value we get inside the start index, we will need to return that. Okay, remember that here we have already got the array sorted and rotated. That is a must. And one more thing, the array is sorted in the ascending order and then rotated. If at all the array is sorted in the descending order, you just need to exchange these conditions here so that you will get the solution for the other that specific sorted array as well. Okay, now let's just try to call this function and validate. So here is this sorted and rotated array that I have given 1 2 3 4 5 and 1 2 3. This is not a sorted and rotated array. So let me just start giving the values from the beginning so that you will have a better understanding. So let's just say 1 2 3 4 5 6 is the complete sorted array. Now to rotate this array let's just say 3 times, what I will do is I will copy 1, 2, 3 and I will paste it at the end of the array. Now this array is basically sorted and rotated 3 times. Okay. Now in this array the maximum value is 6, right, and it is at index 2. So if I run this program right now, the output that we should get should be 2. So let me just run it right now and see the output that we have got is 2. Okay, and let's just say here instead of 1 we have 7. Okay, 7. If I run this right now, see the output that I have got is 3. Okay, because the index 3 has the value 7. Now to test the other scenario where we have only one value in the array. Now we have only one value, right? If I run this right now, run as Java application, see the output that I have got is 0. Similarly, let's just say the array that I have passed is empty. In that case, if I run this program right now, obviously we will get -1. Okay, remember that whatever the array that we have got is sorted and rotated at least once. Okay, then only whatever the solution that we have written for getting the index of the maximum value will work. Now we will basically use this logic in the next problem where we will basically try to search a particular value in a entire sorted and rotated array. Okay, in the next video we will be talking about the algorithm as well as the usage of this while implementing the solution using the binary search there. Okay, anyway, that is the way we find the index of the maximum value in a sorted and rotated array.